It is the study of the motion of an object without discussing the causes of motion. Give a short response to the following questions. In a park, children are enjoying a ride on Big Wheel show. What kind of motion the big wheel has and what kind of motion the riders have? Answer: motion of big wheel is rotatory motion as it rotates about its own axis, while the riders experiences circular motion along the edge of the wheel. Big wheel is rotatory about its axis, so the motion of the wheel is rotatory motion. A body move for some time. Give two situations in which his displacement is zero but covered distance is not zero. Answer: if starting and ending points are same, then displacement will be zero. Case 1. When a boy moves in a straight line from A to B and come back from B to A. 5m. AB. His displacement is zero because starting and ending points are same but distance s is not zero, which is equal to 5 plus 5 is equal to 10 cm. Case 2. When a boy moves on a circular path, then his displacement is zero because starting point and ending point are same, but distance is not zero, which is equal to 2 pi, 3,600. A stone tied to string is whirling in circle. What is direction of its velocity at any instant? Answer: when a stone moves in circle, then the direction of its velocity is always tangent to the circle, which is perpendicular to the direction of centripetal force or radius of circle. Is it possible to accelerate an object without speeding it up or slowing it down? Answer: yes, it is possible. Example: when an object moves in a circle path with constant speed, the object has acceleration due to change in direction. Can a car moving towards right have direction of acceleration towards left? Answer: yes, if the car is slowing down, decelerating, its acceleration is towards the left even if it moving towards right. With the help of daily life examples, tell the situations in which acceleration is in the direction of motion. Acceleration is against the direction of motion. Acceleration is zero and body is in motion. Answer: A. If a car is moving on a straight line with increasing speed, then the acceleration is in the direction of motion. B. When we apply brakes, then the speed of the car decreases and deceleration is produced. In this case, the acceleration is against the direction of motion. C. If the car is moving with uniform speed in a straight line, then its velocity does not change with time, so in this case acceleration is zero, but the car is in motion. Examine distance-time graph of a motorcyclist, as shown. What does this graph tell us about the speed of motorcyclist? Plot the velocity-time graph for it. Answer: this graph tells us that the speed of motorcyclist is uniform, constant, because it covers equal distance in equal interval of time. A velocity-time graph for above motion will be a horizontal line above the time axis indicating uniform velocity. Which controls in the car can produce acceleration or deceleration in it? Answer: A. Accelerator. Accelerator increases the speed, produces acceleration in the car. Brakes. Brakes decreases the speed, produce deceleration in the car. Steering. Steering changes direction, which affects velocity. These controls ensure the driver can respond safely to road conditions. If two stones of 10 kilograms and 1 kilogram are dropped from a 1 kilometer high tower, which will hit the ground with greater velocity? Which will hit the ground first? Neglect air resistance. Answer: both will hit the ground with same velocity and same time, as acceleration due to gravity is independent of mass. A 100g ball is just released from rest, and another is thrown downward with velocity of 10 meters per second, which will have great acceleration. Neglect air resistance. Answer: there we consider two steel ball. Each of ball has 100g, so the one is released from rest and other is thrown downward with 10 meters per second velocity. Both of balls are moving under the force of gravity with an acceleration g equals 9.8 m/s. So both of balls will have same acceleration independent of their m. Exercise long question. Differentiate between rest and motion. With help of examples, show that rest and motion are relative to observer. Answer: rest. An object is said to be at rest when it does not change its position with respect to its surroundings. Motion. An object is said to be in motion when it changes its position with respect to its surroundings. Object can be at rest and in motion at same time or. Example to show relativity asterisk. A person sitting inside a moving train is at rest with respect to another passenger, but is in motion with respect to a person standing outside the train. This shows that rest and motion are relative and depend on the observer's frame of reference. What are different types of motion? Define each type of motion with examples from daily life. Answer: types of motion. There are 3 types of motion are as follows. I. Translatory motion, a type of motion in which all points of a moving body move uniformly in the same line or direction. Examples: a person walking and a bus moving down the street are examples of translatory motion. Translatory motion is further divided into 3 types. Rectilinear motion. The motion of a body in a straight path is called rectilinear motion. Examples: the motion of a train on tracks and the motion of a falling apple are examples of rectilinear motion. Circular motion. The motion of a body in a circular path is called circular motion. Examples: the motion of a football when kicked and the motion of a roller coaster are examples of circular motion. Random motion. An irregular motion of a body is called random motion. Examples: the flight of a kite through the sky and the motion of a butterfly are examples of random motion. 2. Rotatory motion, a type of motion in which a body rotates around its own axis. Examples: the motion of the Earth around its own axis and the rotation of a fan are examples of rotatory motion. 3. Vibratory motion, a type of motion in which an object moves back and forth repeatedly around a mean, fixed position. Examples: a pendulum, swings, and a tuning fork are examples of vibratory motion. 3. What are scalars and vectors? Give examples. How are vectors represented symbolically and graphically? Answer: scalars. Scalars are physical quantities that have only magnitude, size, and no direction. Examples: length, speed, work, mass, density, charge, distance, time, temperature, etc. Vectors. Vectors are physical quantities that have both magnitude and direction. Examples: velocity, force, displacement, acceleration, momentum, weight, etc. Symbolic representation of vectors. Symbolically, a vector is represented by a bold letters or an arrow drawn above it. For example, V or. Graphical representation of vectors. Graphically, a vectors can be represented by an arrows. The length of the arrow indicates the magnitude of the vector. The direction of the arrow indicates the direction of the vector. 4. Define the term position. Differentiate between distance and displacement. Answer: position, the location of an object in space relative to a reference point called origin. For example, the position of school from home. Feature: distance. Displacement. Type: scalar. Vector. Definition: total path covered. Shortest path from initial to final position. Direction: no. Yes. Value: always positive. Can be positive, negative, or 0. Example: 10m walked. 6m to the east. 5. Differentiate between speed and velocity. Also define average speed, uniform and variable speed, average velocity, uniform and variable velocities. Answer: feature. Distance. Displacement. Type: scalar. Vector. Definition: rate of change of distance. Rate of change of displacement. Direction: no. Yes. Example. Walked 10 meters per second. Walked 10 meters per second to the east. Average speed. Definition. Average speed is the total distance traveled divided by the total time taken. Characteristics. It is a scalar quantity and does not account for direction. Formula. Average speed equals total distance / total time uniform speed. Definition. When an object moves with a constant speed, covering equal distances in equal intervals of time. Characteristics. The speed remains constant throughout the motion. Example. A car traveling at a constant 60 kilometers per hour on a straight highway. Variable speed. Definition. When an object's speed changes over time. Characteristics. The speed is not constant and can increase or decrease. Example. A car accelerating from 0 to 60 kilometers per hour and then decelerating. Average velocity. Definition. Average velocity is the total displacement divided by the total time taken. Characteristics. It is a vector quantity and depends on the direction of displacement. Formula. Average velocity equals total displacement / total time. Uniform velocity. Definition. When an object moves with a constant velocity, covering equal displacements in equal intervals of time. Characteristics. Both the speed and direction remain constant. Example. A train moving straight on a track at a constant speed of 80 kilometers per hour. Variable velocity. Definition. When an object's velocity changes over time. Characteristics. Either the speed or the direction, or both, change. Example. A car turning while speeding up or slowing down. 6. What are freely falling bodies? What is gravitational acceleration? Write down sign conventions for gravitational acceleration. Write 3 equations of motion of a freely falling body. Answer. Freely falling body. Objects falling under the influence of gravity alone, with no air resistance, called freely falling body. An object that is moving only because of the action of gravity is said to be free falling body. For example, a ball falling under the action of gravity. Gravitational acceleration. The acceleration of freely falling bodies due to Earth's gravity is called gravitational acceleration. Its value is approximately 9.8 m/s superscript 2 downward. It is denoted by g. Sign conventions asterisk. The value of g is positive if a body is moving freely in downward direction, and the value of g is negative for bodies moving upward. 3 equations of motion of a freely falling body. I. Vf equals vi plus gt for upward, and Vf equals vi, gt for downward 2. H equals vit plus 1 gt2 for upward, and H equals vit, gt2 for downward. 2. 3. Vf plus phi equals 2 gh for upward, and Vf plus phi equals 2 gh for downward. Topic-wise questions answers, Old Book. 5 Quetzales describe the direction of acceleration of a moving body when its velocity is increasing v, decreasing or. Under what conditions acceleration of a body is positive and negative? Answer. A. Acceleration of a moving body is position and is in the direction of velocity if its velocity is increasing. Acceleration of a moving body is negative and is opposite to the direction of velocity if its velocity is decreasing. Note: negative acceleration is called retardation or deceleration. Q.5 A moving body. Moving has uniform velocity. What will its acceleration? 2013. Can a body moving at a constant speed have acceleration? 2017. ANS acceleration will be 0 when the body in a straight line, but there may be acceleration when its direction is changing, as acceleration is the rate of change in velocity. Graph. Graph is the way of presenting information about the relation between various quantities in the form of picture. One of the quantities is called independent quantity and the other is called dependent quantity. 6 quetzales, what is the purpose of distance-time graph? How it is plotted. Answer: distance-time graph. It is useful to represent the motion of objects using graphs. The terms distance and displacement are used interchangeably when the motion is in a straight line. Similarly, if the motion is in a straight line, speed and velocity are also used interchangeably in a distance-time graph. Time is taken along horizontal axis and distance covered along vertical axis. DM. 7 quetzales, sketch a distance-time graph for a body at rest. How will you find the speed of a body from this graph? Answer: the line parallel to the time axis on a distance-time graph shows that speed of the object is 0 or the body is at rest. Speed of the body equals slope equals 0. 8 quetzales, sketch a distance-time graph for a body starting from rest. How will you determine the speed of a body from this graph? Or, sketch a distance-time graph for a body starting from rest. How will you find the speed of the body from this graph?
1 dm.
Distance-time graph showing constant speed is straight line. Its slope gives the speed of the object. Consider 2 points on the graph A and B. Speed of the object equals slope of line AB. Equals 2 equals 10 meters per second. Note, the speed of an object is said to be constant if it covers equal distance in equal interval of the time, shown in the graph. 9 quetzales, what would be the shape of a speed-time graph of a body moving with variable speed? Answer: definition: when a body does not cover equal distance in v/m/s, equal interval of time called variable speed. In the distance time graph showing variable speed which is not a straight line. 40. Slope of the curve at any point can be found from the slope of 30, p the tangent at that point. For example, slope of the tangent at 20 p equals 10. P equals m/s0246810 time t. Thus speed of the object at p is m/s. Note, the speed is higher at instant when slope is greater. Speed is 0 when slope is horizontal. Speed-time graph. In a speed-time graph, time is taken along x-axis, and speed is taken along y-axis ts. 1 quetzal, sketch a speed-time graph for a body moving with uniformly changing speed. Uniform acceleration? Answer: graph of an object moving with uniform acceleration would be a straight line shown in figure. Slope of the line gives the magnitude of its acceleration. Consider 2 points A, B then. Acceleration equals slope of AB equals 6. Equals 4. 10 minus 15 equals m/s/2 time 0.5. Note, the area under a speed-time graph represents the distance traveled by the object. Equations of motion. There are the 3 basic equations of motion for a body moving with uniform acceleration. These equations shows the relation between initial velocity 6, final velocity vf, acceleration a time t and Derivation of three equations of motion. Consider a body moving with initial velocity via a straight line with uniform acceleration a. Its velocity becomes vf after time t. Motion of the body is shown by line AB, and the total distance s covered by the body is equal to the total area OBD under the graph AB. Vf equals 6 plus at. First equation of motion. A equals at equals Vf 6 or Vf 6 equals at A. Second equation of motion. Total distance equals S equals area of OBD. Or S equals area of rectangular OCD plus area of increment ACBS equals OA x OD plus AC x BC. As BC equals BD CD. Equals Vf 6. BC equals at S equals 6t plus at 2. 1s equals 6xt plus tx at 2. Third equation of motion. Total distance equals S equals area of OBD. Equals area of trapezium OBD. Equals OA plus BD, XOD. Therefore, area of trapezium equals 2. Or 2s equals OA plus BD, XOD. Or 2sx equals OA plus BD, XODX. As equals. Or 2sx equals OA plus BD, XBC. Or 2sxa equals Vf plus 6, Vf 6. Or 2 as equals Vf2, 6 2. Note 1. TO convert ms 1 to kmh 1. 1 ms 1 equals 3.6 kmh 1. Multiply by 3.6, 2, to convert kmh 1 into ms 1. 1 kmh 1 equals ms 1, divide by 3.6. To convert ms 2 to kmh 2. 1 meter per square second equals 1 ms, 2 equals 12,960 to kmh 2. Multiplying acceleration in ms, 2 by 12,960 to get its value in kmh 2. To convert kmh 2 into 2. Divide acceleration in kmh, 2 by 12,960 to get its value in kmh 2. kmh 1 equals xms 2. Q. Sketch a velocity time graph for the motion of the body. From the graph explaining each step, calculate total distance covered by the body. ANS. The distance moved by an object can also be determined by using velocity graph. Velocity time graph, Vm/s. If an object moves at constant velocity v for time t, then distance covered by a body is AB. S equals Vxt. This distance can also be found by calculating the area under the V. Velocity time graph. Area under Vt graph equals area of rectangle OBC. Equals length x width 0 tcts. Equals OA xoc. Equals Vxt. Equals S. 1. If the velocity increase uniformly from O to V in time t, then average velocity equals VOV equals distance covered equals VOV xt. S equals Vxt. S equals area under OA. Equals area of increment OB. equals base x height.
Hoegewild bo.
S equals vt. Distance time graph. Speed equals slope equals dm. Speed equals constant. Speed equals 0. Speed time graph. Uniform speed. Or uniform or constant velocity. Vm/s. Acceleration equals Ts. Q. 2016a. An object starts from rest. Write down the changed equation for the motion. A and S when an object starts from rest, then 6 equals O, then the three equation of motion are Vf equals 6 plus at S equals Vt plus at 2. 2 as equals Vf2, 6 2. Becomes Vf equals at S equals at 2. 2 as equals Vf2. Note, if the body stops, then Vf equals 0 then. Vf equals 6 plus at becomes 6 plus at equals 0. S equals Vt plus at 2 becomes S equals Vt plus at 2. 2 as equals Vf2, 6 2 becomes 2 as equals 6 2. Note, for free-falling bodies Vf equals 6 plus at becomes Vf equals 6 plus gt.
S égale V plus at 2 B comme H égale V plus GT2.
2 as equals V2F V2 I becomes 2 GH equals 6 2. Note, distance equals displacement and speed equals velocity if the body moves in straight line.